Hey there, Seahawks, it's Miss Adams, and in this video we're going to go over the multiplication rule for dependent events. Alright, so when we calculate probabilities involving one event and another event occurring, we multiply their probabilities. So when you see and, we multiply. If you see or, you're adding. In some cases, the first event happening impacts the probability of the second event. We call these dependent events. In other cases, the first event happening does not impact the probability of the second. We call these independent events. All right, so today we're working on dependent events. So marbles in a bag. In a bag, there are 3 green marbles and 2 blue marbles. And you play a game that costs 50 cents to play. But if you pull out 2 green marbles in 2 attempts without replacement, that means you take one out and you don't put it back in, you win $1. What is the probability you will pull out 2 green marbles? All right, so here's your bag with your 3 green marbles and your 2 blue marbles. The probability without replacement that you'll pull out first a green and then second a green. Well, the probability of getting a green first is 3 out of 5 because you have 3 greens out of 5 in your bag. The second one depends on the first one. Okay, so we're going to assume that you pulled a green out. So now you only have 2 greens left in your bag, and you only have 4 marbles left in your bag. So the second one is a conditional. All right, so second green given you got a green on the first time. And then I multiply, so top times top, bottom times bottom, that gives me 6/20ths, which you can change to a decimal if you want, which is 3/10 or 30% or 0.3. All right, you have 8 coins in your wallet. 3 of them are weighted to give heads an unfair advantage, which results in heads 60% of the time. The rest are fair coins. If you randomly select one coin and flip it 3 times, what's the probability of getting 3 heads? All right, so we have either a fair coin or an unfair coin. 3 out of the 8 coins are unfair. They're weighted. So 5 out of the 8 coins are fair. 3 out of the 8 coins are unfair. Then my options are either heads or tails. So the probability of getting a heads, then a heads, then a heads for a fair coin would be 0.5 times 0.5 times 0.5. Because they're only asking me about getting 3 heads in a row. So I'm not going to go through all of my combinations for 3 coins because that would be a lot. But if it's fair, you have a 50-50 chance. If it's unfair, the probability of getting 3 heads in a row is 0.6 times 0.6 times 0.6. So that would become 0.216. And then you're going to multiply across that branch. So I have a 3 out of 8 chance of getting an unfair coin. And if I get an unfair coin, I have a 0.216% chance of getting a heads. So 3/8 times 0.216 becomes 0.08175. And I did the same thing for my fair coin. So 5/8 times 0.125 gave me 0.078125. All right, they wanted to know what's the probability of getting 3 heads in a row. Well, that could happen with the fair coin, or it could happen with the unfair coin. So probability of fair and 3 heads, and the probability of unfair and 3 heads. I found those 2 probabilities, so I'm going to add them together. And that's going to give me 0.159875, so about 16%. All right, a deck of cards. In a standard 52-card deck, half of the cards are red and half are black. If you draw 2 cards without replacement, what's the probability they are both black? All right, so both black would be half of them are black. So there's 52 cards in a deck. Half of 52 is 26. Then the next one, if I took a black on the first time, well, now I only have 25 blacks, and I only have 51 cards in my deck. Now I multiply these and change it to a decimal. I get 0.245. All right, so the general multiplication rule is the probability of A and B is equal to the probability of A times the probability of B given A. If the events are independent, then the probability of B given A is just going to be the probability of B. All right, go Seahawks.